Assalamualaikum warahmatullahi wabarakatuh. My name is SYAZANI binti NAZIR with matric number AE170030.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL EDANI binti SULAIMAN and my matric number is AE170014.
Introduction. Acute lymphoblastic leukemia ALL is a disease that can be defined as a lymphoblast. It happens when an uncontrollable growth of malignant and immature white blood cell WBC in the body, and this disease is fatal as it affects all the blood and bone marrow, which lead to a vulnerable of human body system. For cells such as red blood cell, platelets, and white blood cell are produced by a bone marrow. Lymphocyte is an immune white blood cell that will protect the body from any virus. Only a mature lymphocyte that will able to fight the virus in a human body. Lymphoblast is an immature cell of lymphocyte. It is a cell that in an early stage development into a lymphocyte, and it is too weak to eliminate any virus in a human body. It has a small structure that contains a nucleus with a fine chromatin that will divide and increase in volume. Lymphoblast has the tendency to divide rapidly. When the lymphoblast cell grows and divides uncontrollably, and it will lead to acute lymphoblastic leukemia, as it can't fight the virus in human body. Different with a lymphoblast, it is an immature white blood cell that is not a lymphoblast. Non-lymphoblasts are also found in the bone marrow and a blood of human body. It is smaller than lymphoblast and also known as a myoblast. White blood cell has a different type of cell, such as neutrophil, eosinophil, basophil, monocyte, and lymphocyte. When an aggressive growth of myoblasts will lead to an acute non-lymphocytic leukemia. Convolutional neural network is used to examine an acute lymphoblastic leukemia or any cancer. The objective of this project is to design a convolutional neural network model for a detection of acute lymphoblastic leukemia ALL. The second one is to apply the knowledge of convolutional neural network on this project. And the third one is to develop skills in conducting programming and the software. Convolutional neural network CNN model. It is a deep learning in advancement of computer vision that has been constructed over a particular algorithm. CNN is a group of neural network and has been approved to be effective as an image recognition. CNN, also known as COVNET, and it is a deep learning algorithm that can take input image and able to differentiate the image accurately. It also helps to reduce the image into form that is much easier to be processed, and it helps to get more accurate result rather than a detection through a naked eye. The command for CNN model of our project. The first layer will include a convolutional with 32 filters, and the second layer is the max pooling, and the third layer is convolutional with 64 filters, max pooling, and the next one is convolutional with 128 filters and max pooling, and we include a flattens, and the last one is dense. Dense network is which is the original picture of neural network, and the performance of a high accuracy of training and data validation can be set by changing the number of epochs and batch size. For this project, we aim to implement the knowledge of convolutional neural network. So for this project, we will use a programming to run the system. In order to run the system, a flowchart was created in order to have a clear and better understanding about this project. Figure 2 shows the flowchart of this project. We start with a start and define a specification and design the CNN encoding and simulate by using a Google Colab. If the simulation is success, we will record the result and end the process. However, when the simulation is unsuccessful, we need to design the CNN encoding once again.
For the first step is we need to use this command. this coding to connect our Google Cloud and Google Drive. So this is the main part to make sure that our Google Cloud and Google Drive is connected. I already connected it, and this code this folder will appear when we connected the both of them. So second step is import the OS. So before we proceed this step, we need to insert our picture in this folder. Like I put here, I use folder name IDB. So in IDB I have folder train and validation. Also in folder train have lymphoblast and non-lymphoblast picture. Also in validation folder I have the lymphoblast and non-lymphoblast folder. So like we can see, this name is we use to connect it with our Google Cloud and Google Drive. So this I use this coding to connect it our my Google Cloud and Google Drive. So when we run, it automatically connected. So for the third step is we use this coding to connect our Google Cloud and Google Drive. This coding for first is content, G Drive, My Drive, Google Colab Notebook, IDB, and Chain. Like I said earlier, that in the chain have a lymphoblast and non-lymphoblast. So for the next coding is I adding lymphoblast and lymphoblast and non-lymphoblast coding for the coding. It same goes to the validation. I use content, G Drive, My Drive, Google Colab, IDB, and validation. And also in validation folder have lymphoblast and non-lymphoblast. Like I said earlier, this is a print. When we print this automatically will print out the same like this, lymphoblast strain length, and this is lymphoblast strain length. So it can read that lymphoblast strain has 91 picture, non-lymphoblast strain also have 91 picture, lymphoblast validation and non-lymphoblast validation has 39 picture. Most of them we have setting it before we insert the picture in the collab notebooks. Okay, in the lymphoblast train, we have 70% out of 130 picture, and validation we have 30% out of 130 picture. Next step is we need to call the TensorFlow, RMS prop, data image data generator, and VGG16. So this is the coding that must to connect our picture and to read the picture. The step 4, this is the coding that we use to read the picture also, and this is the deep coding. The coding for the deep, we need to find the deep of the picture. So this we only use this coding, and we proceed to the model compile optimizer RMS prop LR equal to 0.001 loss binary consentropy and matching accuracy model summary. So this is the table that we get after we run this coding. Because this is a deep coding, so we just need this step, but I will explain later when we run the white coding. There's some a bit different in this step. So we proceed first to the deep coding. Okay, this is a data detergent that we need to put the batch size for the train generator and valid generator. So I put train generator batch size is 20 and validation generator batch size is 1, because validation picture have a smaller number than batch size than train generator. So when recording, it's found 182 images belonging to classes and 78 images belonging to classes, and label the batch shape is 20. So for the next step, okay, this is the e-push. E-push is we need to e-push it. So the step per e-push is 10. E-pushes 10 also, and validation step also 10. So when we run, we get the this value that this is a loss value, so need the accuracy, so that is most accurate actually. So the validation loss is something like difference in between each e-push. And then what I figure out is we need to use the smaller e-push to get the best result. So for the next step is for the last step is to get the graph. So this is the graph that when we use to plot the graph based on our e-push. So the finally we get the graph. This is the best and the most accurate that I get, even though it's something a silly difference in the end of the graph, because it's supposedly end at 9 actually, at 9 like this, but it's end at 8, but it's okay, but it's the most accurate that I get. So we go to the white coding. So at the white coding, the difference is in the step 4 that I said earlier, in this. So this is same with the deep. So this is same with the deep coding, but the difference is we need to adding this coding the convolution based TERAS PF TERAS application VGG16. This is the VGG16 function. So this is a VGG16 function. So when we run is will this coding with this table will appear. So for the next, we can see this is they have total params 14,714,688, but trainable param is 0. As we can see at the deep, the other coding in this step is the total para, the trainable para has a value, but the non-trainable para no value, but this is have value. So the next step is different than deep coding, is the model equal to TERAS model sequential. This is the additional coding that we need, and the result will appear like this. So there is a total params, trainable params, and non-trainable params. So the others coding is still same, and the last result is this. So this is the result that we get. So for me, this is most perfectly that I can get, even though it's something like a bit little error, but I think this is the best one for the white.
As the conclusion, in this assignment, we use lymphoblast and non-lymphoblast picture as our experimental for visual machinery. We also successful of the result convolution neural network using Google Colab. As to mention, this is our first time to use Google Colab. So I think it's a new experience for us to use a new software and new websites to to use this convolution neural network. Next, we using appropriate value of e-push is 10. We use 10 for the old e-push needed, and batch size is 5 for validation and 20 for the training. The final result we get is the most accurate. We also learn to demonstrate the ability to solve the task and analyze the suitable algorithm based on intelligent system design. We can apply this application in the mechatronic industry. I think that's all from us. Thank you.